This is the points, lines, and planes homework assignment. Let's go. So for number one here, are points N, P, Q, and R coplanar? So coplanar are points on the same plane. So again, we have a cube-looking figure. So N, R, Q, and P would be the top of our cube. So yes, they're all on the same plane. They're all on that top plane, that top two-dimensional surface. So this is going to be a yes. Okay, our N, J, P, and Q. So N, J, P, and Q. So N, J, and P are on the front surface. So for any three non-collinear points, they're going to form exactly one plane. And since that plane is the front of the cube and Q is not on it, we know that this is not, that those 4 points are not going to be coplanar. Okay, right? And N, P, and Q all form a plane on the top. And we know that any three non-collinear points form exactly one plane, and that's that top plane. And we know point J is not on it. So we know, again, not coplanar. Okay, are N, M, and L coplanar? N, M, and L. So it's not drawn in here, but they are coplanar. So if you imagine going from the back of the cube and coming on a diagonal up through the cube, that would be the plane, right? So it would come up through here, right? That would be the plane. So even though it's not drawn in there, it is there is a plane there that those 3 points are on. Because remember, any set of 3 points that are not on the same line are going to form exactly one plane. So these 3 points, N, M, and L, are not on the same line. They're non-collinear, a set of non-collinear points. Therefore, they are going to form exactly one plane. So that's a yes. It's not drawn in the diagram, but there is a plane that they are a part of. Again, second diagram is also a cube. We want to name in 2 different ways the plane that contains points F, G, D, and E. So here's F, here's G, here's D, and E. So that's going to be the bottom plane, the base of the cube. To name the plane, we need to pick 3 points that are on the plane that aren't all on the same line. So how about F, G, and D? So we name it plane FGD. Okay. Or we can name it plane, and really any combination there. How about FED? And 5 here are points A, B, D, and E coplanar. A, B, D, and E. So again, we did not draw, that plane is not drawn in there. Okay. And I don't like the question because we really don't know. If this is a perfect cube where all the angles here are 90 degrees, then yes, we do know there's a plane, right? It's going to be the diagonal one that's cutting through, right? It's going to be a diagonal one cutting through like this. Okay, so in that case, the answer would be yes, which is, I think, what they want us to assume. But I don't like the question because why should we assume that? Right? Why should we assume that those are all 90-degree angles? We shouldn't, really. But I think they want us to assume it, so we'll do what I think they want us to do. Right, you would cut through a diagonal plane. Okay. Are B and H collinear? Again, any set of 2 points are collinear, so this is an automatic yes. Right? For any 2 points, there is exactly one line that they can form exactly one line. So for any set of 2 points, you can form exactly one line. So 2 points are automatically going to be collinear. Are CH and E collinear? The answer there is no. They're not all on the same line. So this one is no. Right, B and H, this was BH right here. Okay. That was this one. Okay. It's a line that would go right across our box diagonally. So let's see how much of this we can get in here. Oh, it's frozen. All right. So here's our third diagram. So it's got plane P. Plane P has line TR on it. It also has the point Q on it. And then we have a line ST that's coming up through the plane and intersecting at point T. So the number 8 here is asking name plane P in another way. So we can name planes in two ways. We can use the symbol in the corner, or we can pick 3 non-collinear points on the plane. So we can name this plane TRQ. There's a set of 3 non-collinear points. Okay. What is the intersection of line ST and TR? Well, here is line ST. And here is line TR. So they intersect at point T. Okay, two lines. If two lines intersect, they're going to intersect at exactly 1 point. They might not intersect, but if they do, they're intersecting at exactly 1 point. What is the intersection of line TR and plane P? Well, line TR is in the plane. So again, here's line TR. Okay, there are an infinite amount of points on line TR. And since TR is in the plane, it's intersecting the plane at every single one of those points. So the intersection of the plane and the line is going to be line TR. Right? This line, so when two lines meet, they intersect at a point. When two planes meet, they intersect at a line. When a line intersects a plane, they can intersect at a point like this line does because it's coming up through, or it can intersect on the whole line because the line is contained in the plane. It's part of the plane. Okay, so that one, this line is in the plane, so the intersection is the entire line. What is the intersection of plane P and plane STQ? Well, here we have the intersection of two planes. Okay, so we know it's going to be a line. So STQ. Okay, so we can try and triangulate a plane here. Okay, so we can imagine a plane of some sort. Not very well drawn there, but you can imagine a plane looking something like such. Okay. Probably draw it a little better. And then make this dashed line. And then this will be dashed. I don't know if that looks good, kind of good, a little good. If we make it bigger here. How's that? Right. Anyways, the line is going to be line TQ. Okay. Let me actually then do this plane. Right, and we'll put dots here. Maybe that'll look better. Yeah, I think that looks better. So you have one plane that's slicing up through the red one. The blue one's slicing up through the red one, and it's intersecting at line TQ. Okay, what is the intersection of line SQ and TR? So what are they? SQ and TR, line SQ. And line TR. Okay. So this is again below the plane. Okay, and this is going above the plane. So Are these lines ever going to intersect? No. So there's no solution here. There's no intersection. Okay, line SQ and line TR don't intersect. Right? Two lines, if they intersect at a point, but they don't necessarily intersect. These ones don't intersect. Okay. 13, what is the intersection of plane P and plane STR? Plane P and plane STR. So again, if we try to draw a plane here, plane STR. So let's see if we can't. I'm really bad at drawing planes. That's terrible. Okay. So let's see here. The intersection is going to be line TR. Okay, we know this line, so let's just put it in TR. Right, because those are the 2 points that are in the plane P. Okay, so it's going up and down. So let's put this below. Then we can put this above. And let's see how that looks. That looks okay, right? The plane is cutting up through. We really should have angled this, is what we should have done. How's that? That looks pretty good. That looks really good. That looks awesome. I did a great job after a couple of tries, right? So we can see the plane that contains S, T, and R, okay, is intersecting the plane P at the line TR. Okay. What is the intersection of line ST and line SR? So ST here's ST, here's SR. Okay, they're going to intersect at point S. Okay. What is the intersection of plane P and line SQ? So SQ, dot, 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 dot. Right, it's underneath. So this line SQ is going to come up, intersect at Q, and go up and through. So that's going to be at Q, point Q. Okay. So this is what we want to know how to do if we want force. Okay, if we want to get force on the test, this is the advanced questions we got to know how to do. Okay. The next one still apply to the same diagram. Okay, so which of the following are collinear? So let's see, are T and R collinear? Yes. Right, we don't even need to look at a diagram because we know any 2 points are going to form exactly one line. And since any 2 points are going to form a line, we know 2 points are always going to be collinear. So this is a yes. This is an automatic yes. Okay. TR, SQ, we got a line SQ there. How about ST and R? That's going to be nope. Okay, S is not on line TR. There's only one line you can make out of T and R. R is not on ST, and there's only one line you can make out of ST, right? For every 2 points, there's exactly one line. So the only line we can make with points S and T is this line here. R is not on it. The only line we can make out of R and T is this line. S is not on it. Coplanar. So this we're going to have to keep going up and down for. So SQ and R. Points SQ and R. Okay. That's an automatic, right? Any set of 3 points will always be coplanar. So these are automatic. Don't even need to think about them. They're automatic yeses. Any set of 3 non-collinear points. Okay, so SQ and R are non-collinear. SQ and R are non-collinear. And ST and R are non-collinear, so they're going to form planes. 21 is STR and Q. So STR and Q. So we know TR and Q are all in plane P, but point S is not. And we know for every set of 3 non-collinear points, there's exactly one plane. So there is no other plane besides plane P that can go through these 3 points. And since S is not on that plane, that set of 4 points is not coplanar. So that one is a no. A no. The next one, we have line ST and R, point R. So if we have line ST, we know we have points S and T. So we have 3 points, ST and R. And we know those 3 points are non-collinear. Since those are 3 non-collinear points, we know that they can form a plane. So that one's, again, an automatic yes. Okay, ST and Q. Again, same reasoning here. We have 3 points, S, T, and Q. Those are 3 non-collinear points, so we know they're going to form a plane. That plane is not drawn in the diagram, but that plane would exist. Right? Any set of 3 points that aren't on the same line will form a plane. So this is yes and yes. Okay, ST and TR. Okay, they're going to the question is, are they coplanar? Right, and so how many points do we have with ST and TR? We have ST and R, right? ST, and TR. So we have 3 points. We know any set of 3 non-collinear points are going to be coplanar because they can form exactly one plane. Okay, so that one is also a yes. Same idea here. Line TR and point S. Yes, they are because you have 3 points. TR and Q. Yes, they are coplanar. You have 3 points, TR and Q. As long as they're not all on the same line. Let's double check and make sure TR and S, TR and Q are not on the same line, so we're good. Okay, and then what about TR and SQ? TR and SQ. Okay, TR and SQ. So we know that TR and Q are all in plane P. And again, we know S is not in that plane. Okay, and S can't be in a plane with those because there's only one plane that can be formed by a set of 3 points. So TR and Q can only form one plane, and that plane is point P, and we know point S is not on that plane. So we know that that set of 4 points, TR, S, and Q, are not going to be coplanar. So this one is a... Let's go to the other side, number 28. So halfway through that. All right. Oops. Okay, we want to name line AB in another way. Right, to name a line, we want to pick 2 points that are on the line. So here's line AB. So we can do AC. Okay, we could also do BC, CB, CA. Those would all work. 2 other names for plane Q. So to name a plane, we can use the point in the corner, or not the point in the corner, but the symbol in the corner. Right, Q is not a point; it's just a symbol. Or we can pick 3 points that aren't all on the same line that are in the plane. So how about points A, E, and B? Or points C, B, and D. Plane C, B, and D. Okay, what we can't do is we can't do plane E, B, and D, and we can't do plane A, B, and C. Because you need 3 non-collinear points that are in the plane. Again, the reason was if we have points E, B, and D, we only have 1 dimension. We don't have the second dimension of the plane. Because a line is a 1-dimensional object, the plane is 2 dimensions, and we simply do not know which way that second dimension is if you give us 3 collinear points. We need 3 non-collinear points. We need to triangulate to get our two dimensions. Okay, why is EBD not an acceptable name for plane Q? Okay, that's what we just gave because it's only giving us one dimension, right? EBD, plane EBD. Well, the first reason not acceptable because we don't have the word plane in front of it. Okay, the second reason it's not acceptable is because you only have one dimension. Okay, the other point could be F, and so your plane, right? If this is the plane that's drawn, and we only have the line, we don't know what plane. So E, B, and D could be. They're going to be in a couple planes. They're going to be in the plane that's drawn, but they'll also be in a plane with point F going up and down. Okay, they'll also be in a plane that's going diagonally. Because this is just giving us one dimension. We need that second dimension, which means we need a third point that's not collinear with two of the other ones. Okay. Are the following sets of points collinear? So a line AB and C. So here's line AB. Collinear means points on the same line. So is C on that line? The answer here is yes, it is. Okay, EB and A. So here's line EB. Is A on that line? No, it's not, so it's not collinear. So that's a no. B and F. Yep, any set of 2 points is always going to be collinear. Right, 2 points. For every set of 2 points, there will be exactly one line that connects them, or that they are a part of. Okay, and then F and plane Q. That's going to be a no. That's going to be a hard no. So how many points are in plane Q? There's an infinite number of points in plane Q. So are all of these points collinear? No. Right, there's an infinite amount of lines we can draw within the plane. Right, every plane contains an infinite amount of points and an infinite amount of lines. And you can't possibly have all the points on all of the lines. So that's a big no. That's a definitely not. No way. Not even close. Okay, I think we're still with the same diagram here for the ones down below, 8 through 15. Are E, B, and F coplanar? Okay, again, yes, you have 3 non-collinear points. We can draw a plane, okay, that they're all on. Right, we can draw a plane. Right. Okay. Right, and this is going to be the intersection of those planes. Okay. So E, B, and F, right, are going to be on that plane. Okay. DB and FC. Okay. DB and FC. So here we know that D, B, and C are all on the same plane. They're on plane Q, and we know F is not on that plane. And again, the one postulate that we have tells us that any set of 3 points that are non-collinear will form exactly one plane. Well, we know the plane that's formed between B, C, and D is plane Q, and we know F is not on plane Q, so we know that set of 4 points is not collinear. So that's a no. I mean, not coplanar. Okay, AC and ED. So we know AC is on plane Q, and we know line ED is on plane Q. So here we have an infinite number of points. Okay, but all of these points are either on these 2 lines, and those lines are in the plane. Therefore, all the points on those lines are in the plane, since all the points on all those lines, since all the points on those 2 lines are all in the plane, they're all going to be coplanar. If I confused you, let me say that again. AC has an infinite amount of points. ED has an infinite amount of points. But since AC and ED are both lines in plane Q, all those infinite amount of points are in the plane. So all the points on AC are in the plane. All the points on ED are in the plane. So all the points in AC and ED are all in plane Q. So all of those infinite amount of points are coplanar. Okay. AE and DC. Right. So we know A and E are in the plane. So if we form a line here between A and E, okay, we know that all of those points are going to be in the plane as well. Since A and E are in the plane, we know that the line between them will also be in that plane. So since A and E are in the plane, since they're in plane Q, we know the line that contains A and E will also be in that plane. Because again, we can only have one line that connects A and E. And if they're both in that plane, the line has to be in that plane. Because the line is either in the plane or it intersects the plane at one point. You can't intersect the plane at two separate points and not be in the plane. Okay, so we know line A is in the plane. We know line CD is in the plane. Since we know these two lines are in the plane, the same reasoning applies as with 10. All the points on AE are therefore in the plane. All the points on DC are therefore in the plane. So all the points between them are on the plane. So this is a yes. Okay, F, A, B, and C. So A, B, and C are collinear. So we have a line. That gives us one dimension. F here is going to give us our second dimension. So a plane has two dimensions. So A, B, and C, that's one dimension. Okay, and if we draw a plane such as this, again, not the best artist here. If we can imagine this plane coming up through with F on it, up through that one, up through plane Q, we can see that A, B, and C are all on the plane with F. Okay, so you have a line that's one dimension. The point F is giving us our second dimension. So here's a line on the board. Here's A, B, this was our line. Okay, that's one dimension. Okay, and then point F is over here. We now have a plane like this that goes through all of them. Okay, so that's our second dimension. So this one is a yes. F, A, B, and D. F, A, B, and D. So again, we know A, B, and D are in the plane Q. Okay. And we know those 3 points, any three non-collinear points will form exactly one plane. That's our postulate. So there's no other plane that B, C, and D can be, that A, B, and D can be a part of other than plane Q. And since F is not in that plane, we know these are not coplanar. Take plane Q and line EC. So again, line EC, right, is going to be in plane Q. Okay. So all the points in Q, right, all the points on line EC are in plane Q. So therefore, all the points are going to be the points of Q. So if you combine these two, it's going to be all the points of Q. You've just duplicated them because all the points in EC are in Q, are in plane Q. So yes, all those points are in plane Q. It's basically saying all the points of plane Q are plane Q, right? Because EC is in plane Q, so all the points in EC, in line EC, are in plane EQ. Okay, segment or line FB and line BD. So FB and BD. Okay. And again, we have two dimensions. You have two lines, two dimensions. Again, there's only 3 points here. F, B, and D. Okay, because F is being duplicated. So there's 3 points. And we know 3 points, F, B, and D. That's 3 points that are non-collinear. So we know there's exactly one plane that they're all going to be in. So that means that in that plane, yes, they are coplanar. They are all in a same plane. Not the plane that's drawn, but they are in a plane. All right, we got 2 more sets here. So we want to find the intersections. Here we have a cube. So here we have two lines. Where do two lines intersect? They intersect at a point. So GK and LG. Okay, so they're going to intersect at point G. Planes GLM. GLM, so that's the top plane of our box, our cube. Okay, and LPN. Is this L? Yep, LPN, so that's the front. Okay, so we have two planes there. Okay, we're at the top and the side here, right? Where? There we go. So the top and the front, and where do they meet? They meet right here. So that's going to be line LL. Line LL. Okay. Planes GH, P, and N. And line. So I don't like how they use 3 points there, but okay. I guess they need to tell us that we have a plane here. So it's going to be this plane here. Okay, that's going right through diagonally through our box. Okay, it's a plane going diagonally through our box. Okay. And KJP. So that's the bottom. KJP is the bottom. So they're going to intersect here at PN. Okay. Planes HJN. So HJN is the back. Okay, it's going to intersect plane GKL. GKL. The front. Right, so those planes are not going to intersect, so that is no solution. We have the front plane, we have the back plane, and those planes don't intersect. Okay. 20, we have line KP and plane KJN. So KJN is the bottom. Okay, and then we have line KP. So again, you have to imagine this plane goes on forever in all directions. So it's the bottom of the plane. And then we have line KP. Okay. Line KP. Right. So the whole line KP is going to be our intersection, right? The line KP right here is in the plane. So again, you have to imagine this plane going on forever. That's hard to draw. You have to imagine this plane going on forever. Line KP is part of that plane. So it's part of the bottom plane. So the intersection is going to be the whole line, line KP. Line KM. Oops. So KM. Okay, so here's line KM. Okay, I didn't draw that very well with KM. And then GHL. So GHL, let me draw it better. So we're going up through the box diagonally through M. And then we have KJL, which is the top. So this is going to come up through the top plane at point M. Okay. Right. Okay, and then 22 through 31. So here's our last diagram, our last set here. Okay, we want to name plane P another way, so we want to pick 3 points that are in the plane. So plane ABD. Okay, we want to name plane Q in another way, so plane ABC. Okay, 3 points that are in the plane that aren't collinear. Okay, what is the intersection of planes P and Q? So that's going to be line AB. Again, these planes go on forever, so it's not a segment, it's a line. So line AB. A and C are collinear, yes. Any set of 2 points is collinear. Are D, A, B, and C coplanar? No. A, B, and C are all in plane Q, and there's only one possible plane that A, B, and C can be a part of, and that's plane Q, and we know point D is not part of that. We also know A, B, and D can only be part of exactly one plane, and that's plane P. And we know C is not part of that plane, so we know that's a definite no. Okay. D and C are collinear. Yes, any set of 2 points is always collinear. Yes. It's not drawn on there, but yes. What is the intersection of line AB and line DC? They don't intersect. Here's line AB. Okay, and then line DC is coming down above. So let's see if I can get 2 whiteboards here. So AB, let's see if we can, right? So here's our planes. AB is right here. DB is going to come down and come through here. Okay, it's not going to go through the crease. Okay, so there's no solution on that one. They don't intersect. No solution. Okay, our planes P and Q coplanar. That doesn't make any sense unless they were the same plane, so that's no. The only points they have in common are line AB. Okay, all the other points that aren't AB, they don't have in common. Therefore, those points are not on the same plane. Are line AB and plane Q coplanar? Yes, because all the points on line AB are in plane Q, right? All these points on line AB are in plane Q. They're also all in plane P. So line AB and plane P would be coplanar as well, but all the points on line AB are in plane Q. So that's a yes, coplanar. Okay, are B and C collinear? Yes, all points, all sets of 2, I mean, not all points, but all sets of 2 points are collinear. Okay, so there are some more challenging questions in there. Probably didn't explain them well. If you have any questions, if I didn't explain it well, just let me know, and I will do my best to help you. Okay, but a lot of these were level 4 questions that you're not going to need if you're just trying to get 2s and 3s. Okay.